Students, we are discussing chapter enzymes, right? In these enzymes, go for the next topic. There is types of enzymes, types of enzymes based on chemical composition. What? Based on what? Chemical composition. Based on chemical composition. Based on chemical composition. Right, enzymes are of two types. Enzymes are of how many types? Two types. Based on what? Chemical composition. What are of two types? Enzymes are of two types. What are they? Number one, first one is simple enzymes. What is the first one? Simple enzymes. First one is simple enzymes. Second one is conjugate enzymes. What is the second one, sir? Conjugate enzymes. Conjugate enzymes. Okay. Go for the first one. What, sir? Simple enzymes. Go for simple enzymes. Simple enzymes. Now listen here. Sir, these simple enzymes, they contains only proteins. It means they are made up of only proteins. It means a non-protein part is not present. In which enzymes? Simple enzymes. Therefore, simple enzymes made up of only proteins. They are made up of only what, sir? Proteins. What does it mean, sir? It means a non-protein part is not there in simple enzymes. What is absent? Non-protein part. What is absent, sir? Non-protein part is absent. Non-protein part is absent. Simple enzymes, best example, pepsin and trypsin. What and what? Pepsin and trypsin. Pepsin and trypsin, these two are which enzymes? Simple enzymes. Okay, right? Now go for the second one. What's our conjugate enzymes? What is the second one? Conjugate enzymes, right? Go for the second one. What's our conjugate enzymes? Conjugate enzymes. Sir, conjugate enzymes are also called as holoenzymes. Conjugate enzymes also called as holoenzymes. They are also called as holoenzymes. Okay. Sir, these conjugate enzymes, they contains protein part as well as non-protein part. Therefore, conjugate enzymes, they contains what and what? Protein part and non-protein part. Contains what and what, sir? Contains protein part. Contains protein part and non-protein part. Contains protein part and non-protein part. Sir, this protein part of what's our conjugate enzyme? This protein part of conjugate enzyme is called apoenzyme. Apoenzyme. Non-protein part of conjugate enzyme is called as cofactor. What it is called as? Cofactor. Protein part of conjugate enzyme is called apoenzyme. Non-protein part of conjugate enzyme is called as a cofactor. What it is called as? Cofactor. Right? Therefore, protein part. Which part, sir? Protein part of which enzyme? Conjugate enzyme. Protein part of conjugate enzyme. Protein part of conjugate enzyme is called what, sir? Apoenzyme. It is called apoenzyme. Apoenzyme. Which part it is? Protein part. Okay. Now, sir, non-protein part. What about non-protein part, sir? Sir, this non-protein part Which part, sir? Non-protein part of conjugate enzyme is called as a cofactor. What it is called as, sir? Cofactor. Cofactor. Which part it is? Non-protein part. Sir, protein part is called apoenzyme, right? Protein part is called what? Apoenzyme. Non-protein part is called as what? Cofactor. Therefore, these two together forms which enzyme, sir? Conjugate enzyme. These two together forms which enzymes are? Conjugate enzyme. Therefore, apoenzyme plus cofactor is equals to conjugate enzyme. Now listen this statement. Sir, if this conjugate enzyme, listen the statement. Sir, if this conjugate enzyme wants to show catalytic activity, right? This which part, sir? Protein part. What more? Non-protein part. Both should be there. Both should be there. Listen this statement carefully. Sir, non-protein part is called as what, sir? Cofactor. What is a non-protein part called as? Cofactor. Without cofactor, in the absence of cofactor, without cofactor, that is in the absence of cofactor, conjugate enzyme loses its catalytic activity. It means conjugate enzyme, if it wants to act like a catalyst, what is essential? Cofactor is essential. Absence of cofactor, conjugate enzyme loses its catalytic activity. A conjugate enzyme works like a catalyst when this non-protein part binds to the protein part of the enzyme. Non-protein part has to bind to the protein part of the conjugate enzyme. Then only conjugate enzyme can work as a catalyst. Okay, in the absence of cofactor, right, conjugate enzyme loses its catalytic activity, right? I am writing this statement, right? Cofactor. Cofactor means which part of conjugate enzyme? Non-protein part of conjugate enzyme. Cofactor, right, when binds. Cofactor when binds to which part, sir? Protein part. Protein part of enzyme. Then what happens? Then only what, sir? Conjugate enzyme. Then only conjugate what, sir? Enzyme. Then only conjugate enzyme can act like a catalyst. Sir, when a conjugate enzyme can act like a catalyst, sir? When cofactor binds to protein part of the enzyme, then only this conjugate enzyme can act as a catalyst, right? See this statement. Conjugate enzyme. What, sir? Conjugate enzyme loses. Conjugate enzyme, right, loses its catalytic activity. See this statement? Conjugate enzyme loses its catalytic activity in the absence of cofactor. This statement clearly indicates that if cofactor is present, then only conjugate enzyme gets its catalytic activity, can act like a catalyst. In the absence of cofactor, a conjugate enzyme loses its catalytic activity. Okay, right? Sir, we are discussing about what, sir? Cofactor. What it is, sir? Cofactor. What it is? Cofactor. Sir, these cofactors are of three types. Cofactors are of how many types, sir? Cofactors are of three types. Cofactors are of three types. Sir, what are these three types of cofactors, sir? First one is metal ion cofactor. What is the first one, sir? Metal ion cofactor. Metal ion cofactor. Metal ion cofactor. Sir, this metal ion cofactor is an inorganic cofactor. Metal ion, inorganic. Therefore, it is which cofactor, sir? It is a inorganic cofactor. It is a inorganic cofactor. Sir, what is the second one, sir? Organic cofactor. What is the second one, sir? Organic cofactor. Organic cofactor. But in turn, these organic cofactors are of two types. What are they, sir? First one is coenzyme. Second one is prosthetic group. What is the second one, sir? Prosthetic group. Prosthetic group. See here, sir, coenzyme and prosthetic group, these are two types of organic cofactors. Okay, therefore that's why while telling what I told, cofactors are of three types. What are they? Metal ion cofactor or inorganic cofactor. Second one is coenzyme. Third one is prosthetic group. Coenzyme and prosthetic group. These are two types of organic cofactors. Okay, therefore cofactors are of three types. First one is metal ion cofactor or inorganic cofactor. Second one is coenzyme. Third one is prosthetic group. Right? Go for the first one. What it is? Metal ion cofactor. Right? To one. What it is? Metal ion cofactor. Right? Metal ion cofactor. Sir, metal ion cofactor, nothing but inorganic cofactor. Right? What it is? Inorganic cofactor. Inorganic, what's a cofactor? Inorganic cofactor, right? Now listen this statement. Sir, metal ion, what? Cofactor. Cofactor means which part of enzymes are non-protein part of an enzyme. Sir, non-protein part should bind to what? Protein part. Sir, metal ion cofactor binds tightly to the protein part of the enzyme. How it binds? Tightly to which part of the enzyme? Protein part of the enzyme. Therefore, metal ion. What's sir? Metal ion cofactor. Metal ion cofactor binds how? Binds tightly. Binds tightly to what? Binds tightly to protein part of enzyme. Which enzyme? Conjugate enzyme. Yes or no? Right? Therefore, in a conjugate enzyme to the protein part, this metal ion cofactor binds tightly. Binds tightly. Sir, for example, this is a conjugate enzyme, sir. This is protein part of the conjugate enzyme, sir. What is this one? Protein part of the conjugate enzyme. Protein part of the conjugate enzyme. Sir, in the introductory classes, okay, right, in the introduction of enzymes, I told one statement. Sir, protein bends along its own backbone and forms many pockets or crevices. One of that pocket is called as what, sir? One such pocket is called as active site. What is this called as a active site? What is that site called as a active site? Active site. Sir, protein means made up of amino acids. It means this what? Active site also contains what? Amino acids. This active site contains many side chains which are made up of amino acids. Contains many side chains, okay, which are made up of amino acids. Okay, sir, this metal ion cofactor, it forms coordination bonds with the side chains present in the active site. Sir, in this active site, actually what comes and binds, sir? Substrate. With that substrate also this metal ion cofactor forms coordination bonds. Therefore, metal ion cofactor forms coordination bonds with the side chains present in the active site. It also forms coordination bonds with what, sir? Substrate molecules. Okay. Therefore, metal ion. What, sir? Metal ion forms what? Coordination bonds. Coordination bonds. Forms coordination bonds, right, with what? Coordination bonds with side chains coordination bonds with side chains of what? Active site and also with what? Substrate. Is this statement okay? Sir, this metal ion, it is forming coordination bonds with what, sir? With the side chains of active site, as well as it also forms coordination bonds with what, sir? Substrate. What are the examples for metal ion cofactors? Examples of metal ion cofactors. In mineral nutrition chapter, we classified essential elements, right, into 4 groups, 4 broad categories based on diverse functions. Remembered? There, right, we discussed one box where essential elements acts as activators of enzymes. Activators of enzymes. That complete box is example for metal ion cofactors. Mg+2 acts as a metal ion cofactor for Rubisco. Pepcase, that is pep carboxylase. Yes or no? Mg+2 is a metal ion cofactor. Mg+2 is a metal ion cofactor for what, sir? Rubisco and pepcase. Okay. Manganese, Mn, acts as a metal ion cofactor for IAA oxidase. IAA oxidase, who is a metal ion cofactor? Manganese. Nickel acts as a metal ion cofactor for which enzyme, sir? Urease enzyme. Iron acts as a metal ion cofactor for catalase enzyme. Sir, for carboxypeptidase, alcoholic dehydrogenase. Yes or no? For these enzymes, zinc acts as metal ion cofactor. Yes or no? Therefore, we discussed a number of examples there. All that examples comes under what, sir? Metal ion cofactors. Metal ion cofactors. Mg+2. Metal ion cofactor for Rubisco. Okay. Pepcase. Manganese. Right. Mn+2. Metal ion cofactor for IAA oxidase. Nickel. Metal ion cofactor for urease. Iron, metal ion cofactor for catalase. Okay. Zinc, metal ion cofactor for carboxypeptidase. Carboxypeptidase. Alcoholic dehydrogenase. Okay, right? Now go for the second one. What's, sir? Coenzymes. What, sir? Coenzymes. Sir, these coenzymes are organic cofactors, right? Organic, inorganic, they are organic cofactors. They are organic cofactors. Organic. Sir, these coenzymes, what it is, sir? Coenzymes. Sir, all coenzymes are cofactors. But do all cofactors are coenzymes? No. All coenzymes are what, sir? Cofactors. All coenzymes are cofactors. But all cofactors are not coenzymes. They are not coenzymes. Okay. Sir, all coenzymes, they are what, sir? Cofactors. But all cofactors are not coenzymes. Okay. Now listen this statement. Sir, coenzyme, nothing but a cofactor. Cofactor means non-protein part. Non-protein part means should bind to which part of the enzyme? Protein part of the enzyme. Yes or no? Sir, coenzyme means it is a cofactor. Cofactor means non-protein part. This non-protein part should bind to protein part of the enzyme. This coenzyme binds loosely to the protein part of the enzyme. Binds loosely to the protein part of the enzyme. Therefore, coenzymes binds loosely. Binds loosely to what? To protein part of enzymes. Which enzymes? Conjugate enzymes. Okay, now listen this statement. Sir, this binding of coenzyme to the protein part of the conjugate enzyme is a transient phenomena. Transient, temporary. Only during catalytic activity, this coenzyme binds to the protein part of the enzyme. Sir, the binding of coenzyme to the protein part of the conjugate enzyme is a transient phenomena. Transient, temporary. Only during catalytic activity, it means when a conjugate enzyme wants to act like a catalyst, at that time the coenzyme binds to the protein part of the conjugate enzyme. Therefore, binding of what? Conjugate enzyme to the protein part is a transient phenomena, right? Therefore, binding of what, sir? Coenzyme. Binding of coenzyme to which part? To protein part. To protein part of which enzyme? Conjugate enzyme is a transient. What it is, sir? Transient means temporary. That is only during which activity? Catalytic activity. Only during catalytic activity. Only during catalytic activity coenzyme binds. Coenzyme binds. Only during catalytic activity coenzyme binds to protein part of the conjugate enzyme. Sir, this conjugate enzyme, which enzyme we are discussing? Conjugate enzyme. To the protein part of the conjugate enzyme, what has binded? Coenzyme. How? Loosely. When? During catalytic activity. Binded loosely. When? During catalytic activity of the conjugate enzyme. Now, listen this statement. In most of the coenzymes, the main component is a vitamin. Most of the coenzymes, right? What is the main component? Vitamins, main component, right? Therefore, in what? In most of the, right? In most of the coenzymes, what, sir? Vitamins are main components. Is this statement okay? Right? Therefore, most of the coenzymes, who is a main component present, sir? Vitamins are the main components, right? Right. Now see this statement. In most of the coenzymes, vitamins are the main components. For this statement, I am writing examples. Okay, right? Sir, coenzymes. What is the main component? Which vitamin is present as main component? Okay, right? Number one, go for the first coenzyme. That is a NAD. What is, sir? NAD. What is the full form of NAD, sir? Nicotinamide adenine dinucleotide. Nicotinamide adenine dinucleotide. Sir, in this coenzyme, what is the vitamin, sir? Niacin. Sir, this niacin is a vitamin B3. Right? Next, number 2, go for the second one. What it is, sir? NADP. What it is, sir? NADP. That is a nicotinamide adenine dinucleotide phosphate. What it is? Nicotinamide adenine dinucleotide phosphate. It's already there. That's why I'm not writing. I'm not repeating it. Right? Nicotinamide adenine dinucleotide phosphate. Okay. Sir, what is the main component? Which vitamin is present? Here also it is what's sir? Niacin. Niacin, that is B3. Okay, right. Therefore, NAD and NADP, what is present, sir? Niacin is present. Okay. Now go for number 3, third one. What is FMN? FMN. That is a flavin mononucleotide. What is, sir? Flavin. FMN, that is a flavin mononucleotide. Flavin mononucleotide. Sir, here what is present as a vitamin, sir? Riboflavin. What, sir? Riboflavin. That is a vitamin B2. Vitamin B2. Now go for number 4. What, sir? It is flavin adenine dinucleotide. Flavin adenine dinucleotide. Here also what is present, sir? Riboflavin is present. What is present, sir? Riboflavin is present. That is a vitamin B2 is present. Riboflavin, that is a vitamin B2. Okay. Next one. Go for the next. Coenzyme. What's a vitamin? Coenzyme and vitamin, right? Next go for number 5. What's it is? Coenzyme A. Pantotheric acid. What it is, sir? Pantotheric acid. Right. Number 6. TPP. What is the full form, sir? Thiamine pyrophosphate. Sir, which vitamin is present here, sir? Thiamine. Sir, thiamine means what, sir? Vitamin B1. Okay, right? Go for the last type of cofactor. What it is? Prosthetic group. What it is, sir? Prosthetic group. Sir, it is a organic cofactor. Which cofactor, sir? Organic cofactor. It's a organic cofactor. Sir, how it binds? Prosthetic group binds tightly to protein part. Binds tightly to what, sir? Protein part of conjugate enzyme. Protein part of what, sir? Conjugate enzyme. Sir, in plants during various metabolic reactions, hydrogen peroxide is produced. Sir, this hydrogen peroxide is broken into water and nascent oxygen with the help of which enzymes are? Peroxidase and catalase enzyme. Which enzymes are? Peroxidase and catalase enzyme. See this statement? Sir, hydrogen peroxide, it is toxic to plants. This hydrogen peroxide is broken into water and nascent oxygen with the help of peroxidase and catalase enzyme. Okay, right? Sir, for this peroxidase enzyme, okay, right, heme group acts as a prosthetic group. Therefore, what's, sir? Heme group. Heme group is a what's, sir? Prosthetic group. Heme group is a prosthetic group of which enzyme? Peroxidase enzyme. It is a prosthetic group of which enzyme, sir? Right, peroxidase enzyme. Therefore, heme group is a prosthetic group of peroxidase enzyme. Right? Thank you.